All right, deck of cards. All right, this guy. All right, so let's see what we're looking at here. We got our objective. It's going to be structs classes are used extensively. This assignment is designed to help you understand the difference between classes and structs so you can choose the best construct for your needs when building your own applications. Natural question whether you use class or structs. This will become more and more clear as you use both of these and see the differences. So in my lecture, I kind of went over classes and structs and the differences between them, all right? So it's pretty obvious what the difference is, just pass by value or pass by reference, right? So what are we going to do here? We're going to create a struct called card. We're going to give the card struct property. All right, let's do this. Let's just follow the instructions, right? So we're going to create a new Xcode playground. We're going to call this deck of cards demo. Save it, desktop. All right, let me make this a little bigger. This is good, right? It's good? Okay. Cool, so let's just follow let's put this guy on this side and this one on this side.
Can you do the other way because the light is
Oh,
right.
okay.
Thank you.
Your wish is my
It'll be like
command.
that for each one. Yeah, everyone are all like it's different light, different places. That's fine.
Okay.
Oh, you can see the one.
All right, so as long as we can see what the requirements are, we can just follow the steps, right? So don't need that. All right, let's go ahead and build a struct called card. All right, there we go. So we give the card struct a property of value, which will hold the value of the card A through K. This value would be a string, okay? So we give this guy a variable called value. It's going to be a string.
Where
So-
do we put the value though of the value? The A2, 3, 4, 5, 6.
We
Put that in the
we will put that in the in the deck later. And let me kind of explain. So think of this as like your node, right? In a singly linked list, a node has a value and the next, right? So very similarly, each card is similar to a node, except it doesn't hold a pointer to another card, but it just contains some info about itself, and that is a value. So it's an object that has a property called value, and that property is going to be a string, right? And that's all. So what it's telling you here is that later on, when we create new instances of cards, it's going to be one of these things that will be saved in the value, but not all of them, right? One at a time, right? So one card will have one value. It makes sense if you think about cards, right? So that's all this line is doing, and we just did that, right? We just made the property called value and made it a string. So give the card property called suit, and it's going to hold on to the suit of the card, which is also a string, right? So we do the same thing, var suit, also string, okay? Now we're done with this line here. We're going to do this one, give the card property numerical value, which will hold on to some integer, right? So we got numerical value int, right? And that's it. That's all we need to do for this card object constructor. In this case, it's a struct, right? Two kinds, struct and classes. So this is defining what a card object should look like, right? If we just stop it right here and we say, hey, let's make a card. Let's say we want to make aces of hearts, right? How do we do that, right? We just we can create a new variable, or let's say we create a constant, call this my card, and we just set that equal to a card, right? You notice that when I type CA, it just auto-completed this. And look at that, it's an S, meaning struct, right? This is this guy. So I just press enter, and then I do the open parentheses, and look at that. Automatically it knows what it needs, right? So I need to give it a value, I need to give it a suit, I need to give it a numerical value. So I press enter, and conveniently it highlights the string part, right? The first one. So I can simply just type quotation mark, this is the value, it's going to be, what is it, ace, right? Tab, right? And then it goes on to the next one, right? And here in the suit, I can say heart, tab again, it goes on to the next one, numerical value. Numerical value for ace is going to be 1, right? And now, look at that, all the errors are gone, right? So I've, in effect, I've created a new instance of a card object, right? And I've saved it here on my card. So if I wanted to do something like this, print my card dot, and notice that when I do dot, it just auto-completes all of the properties that a card has, right? So I can select any one of these, say, print me the suit, right? And there we go, heart, right? So this is how we would make one card. Now, the next part, we're going to have to build a deck, meaning that we're going to have to do this like 52 times, right, for each card. Now, we don't do that in the card struct. We do that, when we want to do it in the deck class, right? So, moving on, we're going to create a class called deck, right? So, this stuff, I'm just going to comment this out, so you guys might need to, might want to use this later. So, all right, so now we're going to create a class called deck. Yes.
Mine doesn't show like
Sometimes if your computer is slow, then it'll just lag.
Oh, okay.
Yeah, when I first did this, I had the tiny MacBook, the one with the Core M, and I would have to wait for the autocomplete. And it'll always say it's like an error, but I know there's no error, so I'd have to wait until the error just like is gone. So computer is faster, it makes you a way more efficient iOS developer. Yeah. Okay, so we're gonna make a class called deck, and the same thing, right? Over here, we're gonna give the deck a property called cards of type array of cards. Okay, so variable cards, you have the type array of cards.
Or
Card, right? So you always wanted to have it autocomplete for you. If you're really lazy and you hate typing, you're gonna love Xcode. And the reason why is because not only does the autocomplete save you from typing, it also guarantees that what you're doing is right. Because if you force type a bunch of stuff and it doesn't exist, and it doesn't autocomplete, then chances are there's something wrong, right? So we're going to make it an array of cards. Okay, give the deck a class property called card. When initializing the deck, make sure that it has 52 unique cards in its cards property. Okay, so right here we're declaring this variable, and then, okay, I'm just going to comment this. Okay, declaring the cards array variable.
So you don't do var cards equals card array?
You're going to need to do that,
Okay.
right? So we're declaring it. So we're going to do this, and we're going to initialize it to be empty. Okay. So now there's no errors. The next step we're going to do is actually build the 52 cards to make the deck. Right? So in order to make the 52, the brute force way to do it is just have 52 lines and build it, 52 times, right? But, that's like the brute force way to do it.
Can we just put it in a dictionary?
Yeah, well, the way I like to, that you should be doing it is create arrays for all of the things, right?
Mm-hmm.
So really you just need 2 arrays. You need one for the suits, right? And the suits, it's going to be an array of these strings here. So we got clubs, or I'm just going to copy this. Or I can't, there's no, we'll just type it out. Clubs, spades, club, spade, and we got heart, and then we have diamonds. Okay, that's an array of 4 things. We're going to also create an array of values, and we're just going to make it an array of A all the way to all of the different values. Okay, we got 3, got 4, got 5, and then I'm just going to copy these. All right, so this is 6, 7, 8, 9, 10, then we got 3 more. This is J, Q, K, right? So there we go. We have all of our different values here. Now, the goal here is to build 52 cards and append all 52 of them to this cards array, right?
We need numerical values as well, right?
Well, you don't have to list it in an array. Yeah. So these are the only 2 arrays that you actually need in order to do the loop to create the 52 cards. Right? So we're going to do the loop to create the 52 cards. Right? So the first loop, the outer loop, is going to loop through club, spade, heart, diamond. Right? And in Swift, if we're going to loop through things, we do for and something, right? I'm just going to say S in suits, or let's make it suit, more explicit, right? We could name it anything, right? So for suit in suit, let me just go ahead and print suit, right? Oh, okay, so there's an error here. Why is there an error here?
We would have it in it, expected
Yeah,
declaration.
this needs to be in a function, right? Otherwise, it's never going to run. So we need a init function that will run in the beginning when we instantiate a new deck. So all of our stuff, our logic, should actually go inside of there.
So that just initializes everything that you're trying to do with logic. So you definitely need that in order to get everything started.
Yeah, so this is a function that will run when you create a new instance of a deck, right? So here I can say I'm going to print making a new deck, okay? And then in here we're going to print out for suit in suits. Now nothing's going to happen until I actually try to instantiate a new deck. So let's say let my deck equals to deck, right? Making a new deck, club, spade, heart, diamond, right? So if I make a new instance of a deck, notice that there's a parentheses. This parenthesis means that it's running a function. The function that is running is the init function, right? Okay, so when I create a new deck, it's going to run anything in my init function. So in my init function, I'm going to have the logic to build all of the cards. Okay, so I already know that I can loop through this array to get me each of the, the different suits. Now I need another array, or another loop rather, to give me each of these values. Right? So the second inner loop is going to be for value in values, and here let's just print value, right? So if we take a look at our console here, we got making a new deck, club, and then we got ace all the way to K, and then spade, ace all the way to K, heart, ace to K, diamond, ace to K, right? So we've, in effect, if you count all of these guys, it's 52 of them, right? So now, to make it even more explicit, right, and this is purely for demo purposes to make it more explicit, I'm going to concatenate these values to show you, right? So let's print out, so we got suit is, or let's do this, the suit is suit, or putting the variable in here, right? And then going to make some spaces, and then we say value is value. All right, so we can get rid of that. We can get rid of this. All right, so now it's very clear. Right? Suit, club, value ace all the way to K. Spade, value A to K. Right? So these are going to be our cards. Right? The stuff that we use to build our cards. Right? So since we have all this, right, the only piece of information that we're missing here is the numerical value, right? So if we can figure out how to print the num, right? Let's do this, the colon here, right? So num, this needs to be some kind of number, right? And if we have that, then we can use all the info here, all three pieces of data, to build our card, right? So if we want to have values ranging from, from what is it, 1 to 13, I can simply, every time we start making a suit, or over here rather, I can just go, var num, and we can set that equal to 1, yeah. And then over here, every time you loop through this, we're going to reset the num to be equal to 1 again. And then every time we print out this number, and then we're going to do num plus equals 1. Okay, so if we put num in our string, let's take a look. Do we get what we want? Yeah, looks like we do, right? So we got the piece of information here, here, here to build our card, right? Now, we do the same thing that we did up here to build the card, right? We can say, let my card equal to card with all that. But really what we want to do is we want to append the thing that we build, the card that we build, into that card's array, right? So we can do that all in one line, right? So we're going to build a new instance of a card and append to array, right? So our cards array dot append new element. The thing we're appending is that card that we built, right? So we build a card. Parentheses, boom, auto-completed for us, right? And the same thing, we do it, we just input these things that we've already printed out that we know is the right one to each of these slots, right? So the first one is going to be suit, the next one is going to be value, the third one is going to be num.
The other way around. First one's value.
Oh, okay. Yeah, that's right. Good catch. Value, suit, and then num. Okay.
It has to be in order. Huh?
Yeah, and for a very good reason why, because the reason why they want you to print out explicitly what these are, in addition to actual value that you give it, is so that you don't like flip-flop it around. Right? So, cool. We're missing one parenthesis, and then everything's good, right? So let's comment this one out because I don't want to see that, right? And this looks like at the end of these two for loops here, I should have everything I need in my cards array, right? So let's comment this one out as well. and we're gonna do at the end of the 2 for loops, right? We're gonna print the cards array, right? And if we print that, look at that. It's an array of card objects, right? It looks kind of weird, but that's what it is.
And I thought I had errors. I was like, what
Yeah.
am I doing wrong?
It's an array of card objects. And if I want to see, let's say I want to see the cards array of index 20, and then I will get 1 card. Yeah, see? So that's the 20th one in that array. So each array, and also you can see cards.count, right? So see how many cards there are, 52, right? So that array has 52 cards in it now. So we did this one, give the deck property called cards. When initializing the deck, make sure that it has 52 unique cards in the cards property. Give the deck a deal method that selects the topmost card, removes it, and returns it. Okay, so we're gonna go ahead and let's get rid of this. Right. So inside of our deck, we are going to create a method. Right? This is the deal method. Okay. So the deal method is just a function. We can call it deal. And whenever we invoke this, it's going to do some stuff, right? So here we're just going to print dealing card. Okay. So now outside here, we can say my deck dot deal, and it should print out dealing card, right? So we're invoking that method with the dot deal property, which is this, right? So it says that when we do a deal method, it selects the topmost card. What is the topmost card?
0.
Yeah, it's cards of index 0, right? That's the topmost card. So if we look at that, that's the first card, right? I'm gonna make this run manually because it's like running automatically every time. That's kind of annoying. So this is the topmost card, and what we want to do is we want to remove it and we want to return it. Okay. So if we're gonna get something out of an array, we have a built-in method called cards. That's the array dot. Is it remove? There we go. We remove at. The at means which index. So in this case, index 0, right? Let's see if we can. Let's see if it returns us anything, right? So if I print that, if it prints out down here, then it means it returns it. Good, right? So literally all I need to do is just return the thing that it returns to me after I remove it, right? Like that. So if I run this now, or, okay, see, it's giving me an error because I didn't tell the function that I'm returning a card, right? Strongly typed languages, right? Now there's no errors. Now if I play it, there we go, dealing card, and it's returning that. Now if I print out this, I should see that card that it returned to me. There we go, see? So dealing card, that's the card that this guy printed out, meaning that the deal method took it out, and also, and over here, I can do this. Let's say after I did one deal, I'm gonna do print my deck.cards.count, okay? Just to see how many there are. There should be 51 because I removed one. There we go, 51, right? So now that we know the deal method works, literally I don't even need this print. It's just one line, right? That's it. So this is my deal method. Now let's take a look at the next one. Give the deck a reset method that resets the card's property to contain the original 52 cards, right? Now, you can do this the hard way, meaning that you do all of this again, or you can simply make a copy of the pristine deck right after you've made it and just save that somewhere, right? So I'm going to make another variable here called pristine card, or I just call it pristine. And I'm going to set it equal to the same thing. It's going to be an array of cards, and I'm going to instantiate it to be an empty array. And over here, I know if I print the cards, I'm going to get 52 cards. They're going to be all in order, just brand new. So at this point, I'm going to set my pristine equals to my cards that I just made. And over here, I'm doing stuff to my cards array, but my pristine deck is still, it's saved and it's stashed. It's still pristine, right? So if I want to do a reset method, I can create a function called reset. And all I need to do here is just cards equals to pristine. Just set it back to the original pristine version, right? So no matter what I do to my cards, here I'm just resetting it back to the original copy, right? So here is basically saving a copy of the original array, right? So if we do this, we're going to do my deck dot reset, and then we're going to print out cards.count again, and this time it should print me 52, right? There we go, 51, 52, right? So at this point now, my cards have been reset, right? Everyone good so far? Okay, so now this part is the shuffle, right? So when I did the lamp stack, my first stack, they had a deck of cards assignment in there as well. And your first stack is always your hardest. I was like kind of struggling to think about how do you shuffle things more efficiently. Now, the easy way to do it is just pick a random number within that range, pick another random number within that range. If they're not equal to each other, just swap it, right? And then do that like 100 times. So it's kind of like shuffled, right? But I mean, it kind of like it works, but it's like that's not really how you shuffle cards.
Didn't we do that with the past assignment?
Yeah, it's like very similar, but I think there are more efficient ways. But if you do the random like swapping thing a million times, then that's pretty random, right? So I mean, it still works. There's also another way you can do it where you have this array of things that you want to shuffle, and then you take the index, you start at the beginning index, and then you pick a range from everything that's not that index, and then kind of like, or it's like you have an array, you pick a random number within that array, and you put it into the first one, and then you move your index from 0 to 1, and then you pick another one from within the range, and you put it in that index. Yeah, so you're like picking a random one and just putting it to front, putting it in front, until you all go from the beginning to the end. So it's in effect, it's like random, right? But let's say,
Just for some odd reason, whenever you do the arc for random thing, you do it like you do two different variables, and you do the arc random thing. It comes out with the same number for some odd reason. Inside the function. Not inside the function, inside
get random number in range swept. There we go. To get the range from 1 to 6 or from 10 to 30, you just do that. Right, and I'm gonna show you guys, what this actually means, right? So let's say that we want a random number between 10 and 30, right? This is what we're supposed to do, right? Let's say let random equal to that, and then we're gonna print random. 24. It's between 10 to 30. Right? Now, what is for, let's say, for this one, what is the minimum value that you can possibly get from this highlighted part? 0, right? So if this guy is 0 and you add 10 to it, that means the total here, the minimum can be 10. That's where they got this minimum from. What is the maximum that this will give us? 20, right? So add 10 to it, you get 30. So that's where this range comes from, right? You do a little bit of arithmetic. So it all comes down to this varying property here. This is the variable. And the range of that pretty much dictates what the full range is, with considering the stuff that you add that's static, right? So if I want a value between, let's do this. If I want a value between I to array.count, right? How would I do it? Let's say that I equals to 10, right? And let's say our array equals to this. Okay. What would I put here? So what is the minimum I want? I, right? So if this is 0, no matter what number I put here, the minimum is always going to be 0. So if I get 0 here, then I want it to be at least I, right? That's where I put the I. And then if the maximum is going to be array.count, that means that I plus this number must be array.count, right? Yeah, so over here, it's going to be, so we want our maximum to be array.count.
Minus I.
Yeah, so it's going to be, so if this is array.count, then our maximum is going to be array.count plus I. All right? So we need to minus I here in order for that to be the maximum, right? Oh, why are there semicolons after this stuff?
The formula is 1 for random max minus min, and outside is min.
Yeah. We're going to have to force these to be the same for it to be able to add together, right? I mean, or we can
It has to be outside.
try to add the I, but if we make this an int, then it'll work as well. Right? There we go. Right? And we can print rand, that. There we go, 10. Right? So we got the minimum that we could have gotten. Oh, it's always 10. Oh, it's 12 now. So I guess we were just really, really lucky. Yeah.
Stay there.
Yeah, so we were really lucky. So the thing is that this is only, what, 13 lines long, right? So the count is 13, so that means we're getting something between 10 and 13. All right, so it's, So, if we have this, then if we make a shuffle, we can say our I starts at 0, and it goes all the way up until I is, we can say I is this guy, array.count -2, and then each time we're going to get a range using this formula here to get a range of the other values, and then we're just going to take that and swap it with whatever it is that is in that I. All right? Yeah. So let's do the shuffle method here. All right? And this is not like the only way to do it. I mean, this is just like a fun way that I came up with. All right? So, well, I mean, it could be or could be not, but it works. It does the shuffling. Right? It's going to shuffle. So what we want to do is we want to start for I in 0 to array.count -2.
Can we just leave it at array.count if we want?
Well, if you make it array.count, then the index would be the one after k. Right? We're looking at I is going to be the index. This array is the cards. Right? So it should be array.count minus cards.count -2. So over here, if we print I, right? Let's do my deck.shuffle. If we run this, there we go. We got from 0 to 50. That's going to be our I, right? So we have the I, and we're going to have to also come up with a rand. This is going to be cards.count -I, same thing. And this guy, now we're going to swap I and rand, right? Okay, so we're going to need a temporary variable. We're just going to make one up here, temp. It's of type card, okay? And we're just going to make it an optional, right? So we're going to say temp is equal to, we're just going to swap them, right? We're going to swap cards of I, and then we're going to say cards of I is equals to cards of temp, or rand rather. Oops. And then cards of rand is going to be equal to temp. Unwrapped. There we go. Okay, so we swapped it, right? And we did that 50 times, 51 times. All right, so after that, let's take a look at, in order for us to, better kind of visualize the deck, let's just go ahead and print, let's do a loop. So for C in cards, print C dot value. All right. So yeah, looks like it's pretty random to me, right? So we can shuffle it. And if we want to shuffle it more, then we just put another loop around this and just do it many times, right? I'm not going to do that, but we did it. We shuffled it, right? So we can also do maybe another function. We can say this one is like, show me what you got, right? So we can make a function called show, And then in this function, we're just going to do the same thing that we did up there, right? For C in cards, and we're going to print, let's print out the suit, C.suit. We're going to do val, C.val. And then we're going to do, well, that's all we need, right? Those are two things, right? Value. There we go. So if I get rid of all of these prints, right? If I do the micdeck.shuffle, right now it's not printing anything, right? So if I do my deck.show, it should show me the shuffled deck, right? Shuffled. Right? Now, if I go over here and do my deck.reset, and we move this show after the reset, then we should see the pristine deck, right? Pristine deck, right? So looks like everything is working. All right, so we got done with all of this. Now, finally, create a class called player. Give the player class a name property. Give the player a hand property called of type array of cards, right? So we're just going to do that over here. Let's go ahead and create player class, right? So we're going to make a class called player. Player has, what is it? A name, right? And the name is a string. Make you optional, right? We're going to have a init function. The init function is going to give me a name, right? And that is going to be a string as well. And I'm going to set self.name equals to name, right? So if I create a new player, let's say create new player, I say, var my player, or let's say player 1. Player 1 equals to player with a name. We can give it a name, right? Rick. And over here we can say print player 1 dot name, and it's going to print optional Rick, right? If we unwrap that, it's going to give us Rick, right? So the name is all set. We're going to also give you a property called cards with of type index array of cards, same thing as we did up here, right? So we're just going to copy that, and it's called a hand, right? Player has a hand. So over here, we're just going to make another variable, and this time we're going to call this hand, and it's going to be an array of cards, and we're initializing it to be an empty array, right? So we give the player a draw method of type deck, and is returning a card. It takes in a deck, returns a card, which draws a card from a deck, adds it to the player's hand, and returns it. Okay. We are passing the deck by reference here since it's a class, right? That's important. So here, the player has a draw method. Okay, and the draw method is going to be a function called draw. This guy takes in a deck, and it's going to return me back a card, right? So it's going to take in a deck, which I'm going to name lowercase deck, and it's of type capital deck, right? So this is the name that I'm going to call it. This is the type that it is, right? The error right here is saying that, hey, you said you're going to return a card, you're not returning it. That's what the error is, right? But what I'm going to do is inside of the draw method, all I'm going to do is first, I am going to, well, we can actually do this in one line, right? What we want to do is we want to draw a card and put it inside of our hand. So obviously we're going to have hand.append, right? We're adding a new element to that. And the thing that we're adding is whatever that was drawn from the deck, which is the deal method right here. And it just so happens the deal method returns a card. So if we run the deal method here, or deck.deal, this guy just happens to be returning me a card which I can append to my hand, right? And I'm going to return that as well. So I guess we can't do it in one line. We're going to have to do it like, we're going to create, this is the card that we drew equals to deck.deal, right? And then we're going to append to the hand this card that we drew, and then we're going to return this card that we drew, right? There we go. So right here, we're drawing or dealing from the deck. Here we're going to add that card to our hand. And here we're returning that card. Okay, so that's the draw method for player. Right? So now to test it out, we can say player1 dot draw, and we have to pass in a deck. Right now the only deck I have is my deck, so I'm going to pass in my deck. And now if we look at print player1 dot hand, look at what we got. Look at that, we got this card. We got an array of cards, but it's only one because we drew it, right? So now the hand, let's do this, hand.count, right? So the hand has one thing in it in that array, and if we print out the my deck cards.count, it's going to have one less thing, right? So 1, 52, 51, right? So that one was drawn from this deck and given to this player, right? If we do that again, let's say we do it twice, right? Then we're going to have 2 cards and then 50 cards in that deck, right? So you're kind of like making a little card game here, right? So that's what this is. When the player draws a card, takes it from the deck, adds it to the player's hand, and then returns it. Note how we are passing the deck by reference. Give the player a discard method of type card, takes in a card and returns you a true or false, which discards the card specified and returns true if the card existed and was successfully removed, or false if the card was not in the player's hand. Okay, so basically it's like guess true or false if that card is in my hand. If it's in my hand, then get rid of it. Right? So here, discard method, right? Making a function that takes in, well, the name of the function is called discard. It takes in a card of type card. The return type is Boolean, and the function body has some code in it, right? So if I'm going to take in a card, I want to see if that card is indeed in my hand array or not, right? So I'm going to have to loop through that hand array. So for H, or let's say for C, let's say for H, short key, for H in hand. Now we're looping through all of the cards that we have in our hand, and H signifies one card, right? So how do we know if this card that was passed in is the card of this H in the hand, right? What do cards have in common? How do I know one card is equal to the other card? If the suit and the value both match, right? Then it's the same card, right? So here we're going to do in our conditional, we're going to do check if the suit and the value match. So if it's hand dot, or not hand, but card dot suit equals to h dot suit, and card dot value equals to h dot value, then we know it's a match, right? So here we will return true, or before we do that even, we're gonna have to get rid of it, right? So hand dot remove at index, and what index is that? We don't know, right? So we're gonna have to keep track of it with a counter, right? So var I equals 0, and every time this for loop ends, before it starts up again, I'm going to do I plus equals 1. Right? So in this case, the I will be our index. Okay, so we remove that and then return true. If it's not matching, then we just go ahead and increment I and then do the loop again all the way until the end. And then if the for loop is done and we haven't returned true, we will return false. Right? If we return true, then the function's over. It exits the function. Right? So now there's no errors here. So to test this guy out, we're going to say, let's go ahead and make a card. Or let's do, I guess we can't. We can, here's what we can do. Draw the card, right? We can say, let's, card 1 equals to the card that we drew, right? Now, if we print card 1, we should see that it's a value 2 with a suit of club. Now, if we do this player1 dot discard and we pass in card 1, we know that it's going to be in that deck, in the hand. So if we print out the result, it should print out true. There we go, true. Right? So it works. And I'm sure if you give it a card that doesn't exist in the hand, like maybe if we did this, my card, right? If we passed in my card, it'll return me false because it's not in that deck, not in that hand, right? So that's the end of it, right? So this is the deck of cards assignment, right? It's not trivial, right? It took us 52 minutes just to get through this.
It took you 52 minutes. It took us hours and we
Right.
get through it.
Right, it took me 52 minutes. But yeah, I mean, this is kind of, the thought process that you go and make, right? So it's like a big algorithm. And it's not like I knew exactly what to do from the start. I kind of read through the instructions and we just did it step by step, right? And if we run into something that maybe is something that we've never seen before, or we're not sure of the syntax, we just Google it. And then, if we're doing loops, it's really easy. It's helpful for us to do like these things like concatenating strings to kind of see what it is that we're looking at in that loop, right? So those are all kind of like debugging tools that you can, debugging methods that you can apply to, when you're doing that.
The mistake that I did was I looked at the solution and
Yeah.
that confused the heck out of it.
Yeah, so I mean, and this is for anybody who's listening to the video as well. I have done every single assignment in the iOS platform, so I have the answers, and my answers are generally like better documented than the answer sheets are. So if you look at the answer sheets for any reason and you're like confused, worst case scenario, come to me and say, hey, can I get your answer?
Okay.
And maybe it'll make more sense.
Okay.
Right, so if the answer sheet does it in a way that is slightly different and it's hard for you to understand, just either ask me for help or ask me for my solution.
Cool.
If I'm not like here and it's like late at night, just be like, hey, can you send me that solution? I will send it to you in 2 minutes. Right, it's all on my computer. Okay.
Could you scroll up a little bit? I'm getting errors. I don't know why. That's good.
Here, let me make this a little smaller so you can see more of it.
Can you tell us what like private functions? There's something in this solution. What does that do exactly? And it was used for build deck.
Private functions?
Private function.
Well, anything with a private in front of it is only accessible within that object
Oh, okay.
Yeah. In the class.
So
So you can't do deck dot something that's
build
private.
deck. Okay.
So for example, if I did this, if I said private let social security number equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, right? If I do this, I cannot go down here and be like, oh, let's make a deck. Okay, let's go like my deck or my deck dot SSN. It doesn't exist, right? I can't see it. It doesn't even autocomplete for me. So when I do the dot, out of the things that I can choose, that's it. That's all the things I can choose. It does not include this private variable that I made called SSN
Is it only for object?
for classes.
Of course.
Yeah.
all classes.
So, but if I can access this SSN within this method. So here in the init, if I go like, hey, the first thing you do when you're initializing is print the SSN. Look at that. It's there, right? I can print it out. So if I run this, yeah, so if I run this, oops, what is this? Ah, there we go. See, if I run this, it's running. The first thing I see should be that social security number, right? It's accessible within my object itself, but it's not accessible outside of it, right? That's what the private variables do.
Then public.
Public is just, there's nothing in front of it. Anything that doesn't have private is public.
Okay. Oh.
Yeah.
okay.
So public things I can access with the dot outside of it. So anything that I can do with a dot, all of these guys are public, right? So notice that the SSN is not in here, right? Because that's not visible outside of the object. So it creates this kind of encapsulation where I can hold on to some data and choose to give you part of it or all of it or none of it, depending on who you are. It's not like you can just peek inside and look at and just take whatever you want. I have to explicitly let you, pass it to you for you to have it, right? So
Can you scroll down to shop?
all right, I'm gonna go ahead and stop this video.